In this example, we are going to look at how to use your graphing calculator to help you factor polynomials. For this example, we have 2x cubed plus x squared minus 51x plus 90. I've already set up a window, so if you want to try to type this into your own calculator and borrow my window, this is a window that's going to give us a good look at all of the key requirements and the key characteristics of the polynomial. We'll be able to see end behavior, the x-intercepts, the y-intercept, all those key features. Now, looking at the graph of the polynomial, because it is a cube, we can see on the ends that we have our end behavior that would be suggested by a cube. And we see 3 x-intercepts. Those are the points that we're going to be interested in finding in order to to factor this polynomial. We're going to start off by identifying probably the one that's the easiest to locate, which is this one right here. I have a pretty strong indication based on this graph that that intercept is going to be at -6. But I want to use the functions of the calculator to confirm that result. So I'm going to press second and then go into the calc menu, and I'm going to choose option number 2, which is the zeros. I'm going to use my cursor to scroll to the left of that intercept. So it does go off the screen a little bit, and that's okay. We go to the left of it, then we go up here somewhere to the right of that intersection or that intercept point. And then the guess is just try to move the cursor as close as you can to it, and there's our intercept. Now you'll notice over here that this does not say 0. That does not mean that we did something wrong. That's scientific notation for an incredibly small number that has 10 zeros in it. So we're not too worried about that number. It's close enough to 0 that we can assume that our intercept is going to be at -6. Because the intercept is at -6, we know that one of the factors of the polynomial is going to be the binomial x plus 6. Understanding that as one of the factors of the binomial, we can use synthetic division to further break down that binomial that we started with. Writing our coefficients, the polynomial that we started with. Writing down the coefficients of that polynomial. And as we always do, bringing down our first number. We're going to multiply. And then we're going to add. Then we're going to multiply. And then we're going to add. And then we're going to multiply. And then we're going to add. And we confirm our result that -6 is a root / x-intercept by seeing our remainder of 0 here. This resultant quotient polynomial of 2x squared minus 11x plus 15 is what we will use with that x plus 6 to further factor the polynomial. Using a little bit of AC method on the 2x squared minus 11x plus 15, you could get that the factorization of that trinomial is 2x minus 5 and x minus 3, leaving us with solutions at x is equal to -6, x is equal to 2.5, and x is equal to 3. If we go back to our graph, we see that our two other solutions of 2.5 and 3 are pretty good estimates based on this graph. We have a pretty good idea that that might be where those two, they're a little bit harder to see based on where we set our scale and how we set our scale, but you can see that it's roughly at 2.5 and 3. If you wanted to confirm that, we could go back into the 0 menu, arrow all the way over to the left of 2.5, and then go to the right of 2.5, and then guess, and we see our 2.5. And we can repeat that process with the last 0. We stay somewhere to the left of 3, we go somewhere to the right of 3, and we guess again, and we have our 3. We have to do the 0 function on the calculator one at a time because the calculator will not locate more than one at a time. So we have to set our bounds so that we're only looking for specific ones at a time. Based on this result, it's pretty apparent that we could have used x minus 3 as our starting factor, but it would have been a little bit trickier to use that 2x minus 5. Synthetic division doesn't work if our coefficient of our x term is anything other than 1. And it wouldn't be easy to divide away that 2 from that 5 and try to get something that was a little bit simpler to use. So in reality, we really only had this choice of x plus 6 and that choice of x minus 3 as the one to get the ball rolling. And if we had made a wrong choice, it would have been a little bit more difficult to factor it. But choosing the one that was very obvious way over on the left, way over here on the left, made our factorization much simpler.